Hi, Miss Stoles here. We're working with shapes today. Our objective is to use attributes to identify and draw different quadrilaterals, including rectangles, rhombuses, parallelograms, or trapezoids. Now, we have some important vocabulary that we need to remember. First, let's talk about square corners. With square corners, look at this index card. See how this side is flat and this one is flat and it comes together? Imagine it making the letter L. That is a square corner. We're also talking about parallel lines. With parallel lines, those are lines that run near each other without touching. Think about railroad tracks. Okay, the lines are not going to touch. They're not going to run like this. They're going to run beside each other without touching. Okay, and in these shapes on our screen, we can see some examples of square corners and parallel lines. Look at this green shape. This side, as well as this side, they are running parallel to each other. This side and this side are running parallel to each other. We can also see the examples of square corners in this shape. Okay. If we look at this shape, for example, do we see square corners? How about here? Is this a square corner? No, we're not going to be able to hold our index card up to that corner and it fit. It does not have square corners. What about parallel lines on this shape? If this line extended out and this line extended out, they would cross. So those would not be parallel lines. So let's talk about drawing and identifying trapezoids. Trapezoids have at least one pair of parallel lines. Let's look at our definition. Trapezoids, at least one pair of parallel lines. Here are some examples of some trapezoids. They don't all look the same, but they do all have that one characteristic of having one set of parallel lines. The other set of sides are not parallel. They will eventually cross if they were extended out. Let's see if I can extend out these sides. Okay, if this were extended out, go this way. This side extended out goes this way. What happens at this point? They cross. So those are not parallel lines. However, if we extended out this side and this side, what would happen? Okay. These sides are not going to touch. So these and these two sides are our parallel sides. This side and this side are not parallel. We will find the same with each one of these shapes. One side is parallel, the other side is not and would eventually touch if the lines were extended out. Okay, let's move on to parallelograms. Now with parallelograms, our definition for a parallelogram, a parallelogram has two pair of parallel sides. Let's see what we can do if we extend these sides out. Let's look at this one. If we extend this side out, and as well as this side. We can see they're still going to be parallel. They're not going to cross. They're going to stay parallel. I always think about railroad tracks. Let's check another side of the same shape. Because remember, a parallelogram has two pair of parallel sides. The same with this side. As we extend those sides out, they're not going to touch. So we have trapezoids that have one pair of parallel lines and parallelograms that have two pair of parallel lines. We're also going to talk about rectangles, squares, and rhombuses. Let's look at those definitions. A rectangle has four sides and four square corners. Looking at these examples of shapes on our page, we know that these are rectangles. Well, let's prove it really quick. So, has four square corners. One, making that letter L. Two, three, and four. Okay? It does not say anything about having the same sides. It just says four square corners. That's our rectangle. Now, a square is a special rectangle. It has those four square corners, but in addition to that, each side is equal in length. As we look on this side, we can see that every side of this object, this shape, each side is equal in length. That is the difference between a square and a rectangle. A square is a rectangle because it has four square corners, but it's a special rectangle because every side is the same length.